Assalamu alaikum students. So our first MCQ is, which one among the following is unknown electrolyte in its molten state? Look at here, sucrose. Here option B is correct. What is electrolyte? Electrolyte is a substance which convert into ions in molten or solution form and which conduct electricity. So here we know that sucrose do not convert into electrolyte into ions in molten form, so it is unknown electrolyte. Here option B is correct. Second MCQ. Oxidation is a chemical process in which a substance, option A, gain oxygen, loses hydrogen, loses electron, all of the above. Here option B is correct, okay? Because gain of oxygen and loss of hydrogen, these are the classical definition of oxidation, okay? And this one loses electron, so this one is the modern definition of oxidation. Here option D is correct. Third, oxidation number of chlorine in perchloric acid is, here perchloric acid is HClO4, okay? Here we know that H is +1 and plus chlorine is X plus 4, and we know that oxygen is -2, okay? Now 4 2s are 8 and 1 plus X minus 8 is equal to 0, okay? And here X is equal to +8 and this one -1, so X is equal to +7. So the oxidation number of chlorine in perchloric acid is +7. Here option B is correct. Oxidation number of hydrogen can be, now look at here, in diatomic state the oxidation number of hydrogen is 0. In its compound like H2O, the oxidation number is +1, okay? In metal hydride like lithium hydride LiH, its oxidation state is -1. So here option D is correct, okay? They all can be possible. Look, these compounds are the example in which the oxidation state is 0, +1 and -1. Fifth, which one among the following when added to the acidified solution of potassium permanganate results in oxygen release? Now look at here, when we add this compound, then which one will release oxygen, okay? Now look, when we add the water in acidified solution of potassium permanganate, then in this case oxygen do not produce, okay? None of the gas produce here in case of water. Now here option B is correct. When we add hydrogen peroxide, so it produces oxygen, okay? It produces oxygen. When we add oxalic acid, so carbon dioxide is produced in this case. When we add hydrochloric acid, then here chlorine gas is produced. Now here option B is correct because in MCQ the required is oxygen, so hydrogen peroxide is correct one. 6. Regarding electrolytic and voltaic cell, the true statement is now option A. In voltaic cell, a non-spontaneous reaction generates electric current. This one is incorrect because in voltaic cell a spontaneous reaction occurs, okay? Look at the B option. In voltaic cell a spontaneous reaction generates electricity. Now this one is correct, okay? Because in voltaic cell a spontaneous reaction occurs and in turn it generates the electric current. Look at the C option. In electrolytic cell a spontaneous reaction generates electric current. This one is incorrect because in electrolytic cell non-spontaneous reaction occur, okay? Look at the D. In electrolytic cell a non-spontaneous reaction generates the electric current. This one is also incorrect because in electrolytic cell the current do not produces, okay? So here option B is correct. 7. All of the following statements about Daniell cell are incorrect except, so here in the option we have to find the correct statement, okay? Look at here, A. Copper loses electron. This one is incorrect because in copper the reduction occurs and in case of reduction the copper gains electron, not loses. So this one is incorrect. Look at the next one. Zinc ion gain electron. This one is also incorrect because in Daniell cell what happened? The zinc loses electron. Oxidation occurs at anode and anode in Daniell cell is zinc, okay? So in Daniell cell the zinc loses electron, so this one is also incorrect. Now look at the other option. Copper is oxidized and zinc is reduced. This one is also incorrect. Zinc rod is suspended in zinc sulfate solution. This one is correct. Okay, in Daniel cell the zinc rod is suspended in zinc sulfate solution, and copper rod is suspended in copper sulfate solution. Okay, and here on zinc oxidation occur. Okay, here is the LOANZ. Okay, on left side oxidation occur at anode. Okay, and anode is negatively charged while the electrode is zinc. Okay, at anode the electrode is zinc, so you should memorize this one. Here option D is correct. 8. Having Daniel cell in mind, the incorrect statement is, now look at here. A, copper is reduced. This one is correct. Okay, we have to find the incorrect statement. Zinc is oxidized. This one is also the correct statement. Copper is in direct contact with copper sulfate solution. This one is also the correct statement. Now the incorrect is Daniel cell is rechargeable. This one is incorrect. Okay, here in this case the option D is suitable. Okay, because Daniel cell cannot be recharged again. Okay, so here option D is correct. 9th, in a Daniel cell the magnesium chloride is used. This one is incorrect. Okay, zinc gain electron. This one is also incorrect because zinc loses electron. Zinc act as anode. This one is correct. Okay, in Daniel cell zinc act as anode. It is present on left side of the cell is anode. Okay, on left side, and oxidation occur at anode. Anode is negatively charged and zinc is used as anode. Okay, so here option C is correct. 10th, Daniel cell can be represented as, so there are 3 rules to represent a cell. The first one is anode is represented to the left side. Okay, anode is represented to the left side. Now look at here, we know that in Daniel cell anode is zinc. Okay, so this one is incorrect. Now look at here, the second rule is that cathode is at the extreme right. Okay, so we have to find in this that which one is correct. Now look at here, we know that at zinc the oxidation occur. Okay, because zinc is anode, and at anode the oxidation occur. Now look at here, at option B oxidation has occurred, loss of electron has been occurred. Okay, now look at the D option, here also the loss occur, and look at the C option, here the gain of electron occurred. Look here, +2, and here it is 0, so it means that gain occurred. So this one is incorrect. Okay, because at zinc the loss of electron occurred. Now look at here, this 1 molar is written with ions. Okay, it is always written with ions. Now look at B option, zinc is converted into ions. Okay, and it is present in the solution. Now look at here, copper is cathode. Okay, copper is cathode, and in Daniel cell the reduction occur, which means the gain of electron occur. Okay, and here we know that these ions are present in the solution, so we have to write this 1 molar with copper ion. So here option B is correct. Okay, now look at here, option D, copper loses electron. This one is incorrect. Okay, because at cathode the gain of electron occur, not the loss. Okay, so this one is incorrect. Here option B is correct, because zinc act as anode and anode loses electron, copper act as cathode and cathode gains electron. So option B is correct. Standard hydrogen electrode is connected with an unknown half cell. If the standard hydrogen electrode acts as cathode, so cathode here means that reduction will occur. Okay, then half reaction for the standard hydrogen electrode will be. Now look at here, at cathode we know that reduction occur, gain of electron occur. Okay, now look at here, option A, here the oxidation occurs, so this one is incorrect. Look at the B option, here the gain of electron has occurred, so option B is correct. And we know that when the standard hydrogen electrode SHE act as cathode, then in that case the hydrogen gas is released. Okay, so here option B is correct. Look at the C option, gain of electron occurred but not the hydrogen gas has formed. This one is totally incorrect reaction. Okay, and look, this one is also incorrect because it is directly converted into H2. This one is also incorrect. So the correct statement is option B. The oxidation state of manganese in potassium permanganate is. Now look at here, we know that potassium is +1, okay, plus manganese is unknown, +4 minus 2 is equal to 0, okay. We know that oxygen, for one oxygen it is -2. Now 1 plus x and -8 is equal to 0, so x is equal to +8 and this one -1, so x will be equal to +7, okay. So here option B is correct, okay. The oxidation state of manganese in potassium permanganate is +7. Now 13. Consider the following redox reaction. Here a reaction is given. In this reaction we have to find that how much electron is lost by copper and how much electron is gained by nitrogen, okay. Let's find this one. Now look at here, a reaction is like this, okay. The change in oxidation state occurred from here, copper, and this one, okay, and the change in oxidation state occur in this nitrogen and this one. Now look at here, copper here is 0 and here it is +2. Oxidation state of nitrogen is +5 here and it is +2 here, okay. So the change occur. Now look at here. Here what happened? The loss of electron occur, means the oxidation occur. So copper loses 2 electron. Look, from 0 to +2, it means it loses 2 electron. Look at here, HNO3. It from +5 to +2. It means that it gained 3 electron and then it become N+2. Now look, in order to make these electrons equal, multiply this one with 2 and this one with 3. Now look here, 2 electron, so we have to multiply this one with 2, and here is 3 electron, so multiply this one with 3. So you will get an equation like this: 3Cu plus 6 electron, okay. Here the electron becomes 6 and here the gain of electron also 6, okay. So it means that copper loses 6 electron and nitrogen gained 6 electron, okay. So look at the options. Now in option A it is 2 electron, this one is 3 and this one is 4. It means that these 3 options are incorrect. Look at the D option. Look at the D. Copper loses 6 electron and nitrogen gains 6 electrons. So this one is correct option, okay. Option D is correct. 14. Consider the following half reaction. Here a reaction is given, Cr2O7, here -2, oxidation state of oxygen is -2 and 6 electron is gained, and here it is 2Cr plus 3, okay. The required is that in order to make this reaction balance, how much hydrogen ion will be required, okay. Now look at here. Here are some rules. First rule is that balance the elements other than hydrogen and oxygen, okay. Now look at here, chromium here is +2, here chromium is 2 and here it is also 2. It means that chromium is balanced. Now we have to balance the oxygen, okay. Now in order to balance the oxygen, what you have to do, look, oxygen here is 7. Now on other side of the equation add 7 water, okay, 7 H2O. In order to balance the 7 oxygen, add 7 H2O on other side of the equation. Now look at here. In order to balance the hydrogen, you have to add 2 7s are 14. 14 hydrogen ion here, okay. You have to add 14 hydrogen ion. So this reaction will be balanced. Now look at the option B. 14 hydrogen ion should be added to the left side. So here option B is correct. Now look, first you have to balance the element other than oxygen and hydrogen, okay. Like here chromium, it is balanced already, okay. The second step is that you have to balance the oxygen. For balancing the oxygen, you have to write the H2O, okay, water. Look, oxygen is 7, now write 7 H2O. Now in order to make the hydrogen balance, you have to put the hydrogen ion. Look here, hydrogen is 14, so write 14 H ion, hydrogen ion on other side of the equation. Now look, this equation is balanced, so option B is correct here. If the cell potential is positive, then the reaction will be Look here, option B is correct. Okay, spontaneous in the forward direction. Option B is correct here. Now keep few things in your mind, that if the potential of cell is greater than 0 means positive, and potential of cathode is greater than potential of anode. Okay, and here the enthalpy is smaller than 0. In this case, the reaction will be spontaneous. Okay, the reaction will be spontaneous in forward direction, while in backward direction it will be non-spontaneous. Okay, in backward it will be non-spontaneous, while in forward this reaction will be spontaneous. Now look at option B is correct here, spontaneous in the forward direction. Mass of the substance produced at any electrode is directly proportional to the quantity of electricity passing through the solution and dash of the substance. Look, equivalent weight. Okay, this is the second law of Faraday. Second law of Faraday is W, it is the mass, is directly proportional to the IT. Look, this is the quantity of electricity. Okay, and E is the equivalent weight. So here option A is correct. In lead storage battery, PB and PbO2 act as, now look at here, it acts as anode and cathode respectively. Okay, so here option C is correct. This one act as anode and this one act as cathode. Okay, look at the next one. Anodic reaction for lead acid storage battery is, here option A is correct. Now look at here. Look, this one is the anodic reaction. Pb plus H2SO4, lead sulfate, 2 hydrogen ion and 2 electron. Now look at here. Here it is aqueous. In option A it is aqueous. Aqueous means that we don't have to write this one. Okay, and H2SO4. Here aqueous means that they are already present in ions form. Okay, in ions form, so they have directly written H2SO4 too. Okay, they have directly written the sulfate ion, so you don't have to write the H2SO4. Look here, aqueous is not present. Okay, that's why they have written H2SO4 and here the hydrogen ion, but here aqueous is present, which means that in aqueous form they are already present. This one is already present in ions. Okay, so in ions they have directly written the sulfate ion and PbSO4 plus 2 electron. So here option A is correct. Okay, regarding batteries, all of the following statements are incorrect except that. Look at the A. Primary cells are non-rechargeable. This one is correct. Okay, lead acid battery are non-rechargeable. This one is incorrect because it is rechargeable battery. Secondary cells are also rechargeable and Daniell cell is not rechargeable. So these three options are incorrect and the correct option is option A. In a fuel cell, reactants are continuously added and the product are continuously removed. The reaction for hydrogen oxygen fuel cell is, here we know that the reactants are hydrogen and oxygen and the product is water. Now look at the options. Now look at the option A. Here oxygen is reactant, water is reactant. No, this one is incorrect. Okay, look at the B. Hydrogen is reactant and hydroxyl ion is reactant. This one is also incorrect. Look at the C option. Hydrogen is reactant, oxygen is reactant and water is the product. Here C is the correct option. Okay, because in fuel cell we only use hydrogen, oxygen and water is product. So here option C is correct. Reduction potential of copper is greater than that of magnesium, which means that, now look at here, it means that copper has greater tendency to gain electron as compared to magnesium. Now look at here, following reaction. So we have to find the spontaneous reaction here. Spontaneous means that copper will gain electron and magnesium will lose that electron. Now look at here. Look, copper has gained electron. Here option A is correct, but the problem is that we don't know that from where this electron come. Okay, look at the B option. Magnesium has lost the electron, but from where this electron we don't know that how it has lost the electron, okay, because there is neither oxidation process, neither the reaction process, okay, neither it is here the oxidative agent is present, here the oxidizing agent is not present, okay. Look at the C option. The copper has lost the electron, which means that oxidation occur in copper, which is incorrect, okay, because the reduction potential of copper is greater. So this one is incorrect. Look at the D option. Copper has gained the electron, which means that the reduction potential of copper is greater, and magnesium has lost the electron, okay. So here option D is correct. Magnesium lost the electron and copper gained that one. So here copper acts as oxidizing agent and magnesium acts as reducing agent, okay. So here option D is correct. Consider the following diagram. In this cell, standard hydrogen electrode acts as, now look at here, according to electrochemical series, zinc acts as reducing agent, okay. Zinc acts as reducing agent, which means that oxidation occur at zinc, okay. According to electrochemical series, oxidation occur at zinc, which means that loss of electron occur, and we know that loss of electron occur at anode. So in turn the SHE will act as cathode. So here option A is correct, okay. Here you have to memorize the electrochemical series, okay. You don't memorize their values, but only memorize that zinc act as reducing agent, oxidation will occur at zinc, and reduction will occur at hydrogen, okay. So here SHE will act as cathode, and which means that hydrogen ion will gain an electron, and when this one gain electron, so hydrogen gas will be produced. Like look at here, like this one is electrochemical series, okay. Here hydrogen is present, and above hydrogen zinc is present, and like this other elements are present, okay, and below hydrogen copper and other elements are present. Now keep one thing in your mind, that above hydrogen all the elements will act as reducing agent, which means that all the elements here oxidation will occur in all the elements above hydrogen, and below hydrogen reduction will occur in all the elements, okay. Reduction will occur below hydrogen. Now look at here, two elements are given, zinc and hydrogen. Now if the zinc act as a reducing agent, when the oxidation occur at zinc, it means that reduction will occur at hydrogen, okay. So we know that reduction always occur at cathode, so here SHE will act as cathode. 23. Reduction potential of silver is greater than that of zinc, so it means that silver will gain electron and zinc will lose electron. Consider that small quantity of zinc powder is added to a solution containing silver ion as shown in figure. Now look at here, this one is the solution and silver ion is present here. Now if we add the zinc powder here, then what will happen? Here zinc will lose electron, okay. Zinc will lose electron, oxidation will occur here, and here we know that the reduction potential of silver is greater, it means that this silver will gain electron, okay. The electron which is lost by zinc, it will be gained by silver. So when silver gain that one electron, then what will happen? It will come at the bottom here, okay, in the form of solid, okay, and this zinc will be present in solution in the form of zinc ion, okay. It will present in the form of zinc ion. So this X represent solid silver, okay. Zn plus 2. This X represents solid silver, because silver has gained the electron which is lost by zinc powder. Look here, option D is correct, okay. That X represents the solid silver. Consider the following reaction. Look, lead and silver is given. Here the lead has lost 2 electrons and silver has gained 2 electrons. It means that oxidation occur on lead and reduction occur at silver. So if a cell is made based on this equation, now look at here, lead will act as anode, because we know that at anode the oxidation occur, and silver act as cathode, because at cathode the reduction occur, gain of electron occur at cathode. So here option A is correct. Okay, because at lead the oxidation has occurred, loss of electron occurred, which means that it will act as anode. Here option A is correct. Okay, consider the following spontaneous reaction. Look, nickel has gained 2 electron and manganese lost 2 electron. If a voltaic cell is made based on the reaction, then conventional representation of the cell will be. Now look at here. Here nickel has gained 2 electron and magnesium has lost 2 electron. We know that there are 3 rules for the representation of cell. The first one is that we have to represent the anode on the left side. Okay, anode is that one in which the oxidation occur. Look, oxidation has occurred on manganese. So look at the B option, oxidation occurred at manganese. Now the next rule is that we have to write the cathode half reaction on the right side. Look, reduction occurred at nickel, which means that it will act as cathode, so we have to write it on the right side. The third rule is that just draw the 2 slashes between them. So here option B is correct. 4 statements are given below. The correct statement is, now look, we have to find the oxidation state of nitrogen in NO and N2O5. Look at the C option, this one is correct. Okay, here in this case N is +2 and oxygen is -2. Oxidation state of N is +2 and +5. Now we have to find the oxidation state of this N. Look, 2x plus 5, and we know that oxygen is -2 equal to 0. Now 5 2s are 10, 2x minus 10 is equal to 0. Okay, now bring this one here, so 2x is equal to 10. Now 2 1s are 2 and 2 5s are 10, so x will be equal to +5. Now look at the C, oxidation state of N in NO and N2O5 is +2 and +5 respectively. Okay, here it is +5, so option C is correct here. Which of the following is correct for the life period of the galvanic cell? Now here option A is correct. The life period of galvanic cell increases with the increase in concentration of cathodic solution. Here option A is correct. Okay, and also if we increase the size of what anode. Okay, here the 2 condition is, first is if we increase the concentration of cathodic solution, and also when we increase the size of anode, then in these 2 conditions the time period of the galvanic cell can be increased. Now look at here how it will happen. Look at here, in galvanic cell we know that zinc is the anode and copper is the cathode. Okay, so we know that what happened, this zinc loses 2 electron and it comes to the solution in the form of Zn+2 ion. Okay, when it loses 2 electron, this electron comes to the cathode. Okay, they come to the cathode, and here from the solution copper +2 ion gain these electron and it is deposited on the cathode. Now look at here, if the size of the anode is greater, size of this zinc electrode is greater, then more and more zinc ion will come to the solution and more electron will be lost by it, and these electron will come to the cathode. Then what will happen, if the copper ion is greater in the solution, then these copper ion will be deposited on the cathode. Now look, if the electron is in greater amount, then the copper ion will be deposited on the greater amount. Okay, now look, the electron depend upon the size of the anode and the deposition. Here the copper ion, if the copper ion is in greater amount, then it will gain that electron and it will be deposited on the cathode. So the life period of galvanic cell depend upon the size of anode and the concentration of cathodic solution. Okay, concentration of cathodic solution. while it do not depend upon the concentration of anodic solution and the size of this cathode. Okay, it do not depend upon the concentration of anodic solution and the size of the cathode. Now look at here. The correct option is it increases with the increase in the concentration of cathodic solution, and also it increases with the increase in size of the anode. So option A is correct. Consider the following spontaneous reaction. Look, a reaction is given. A, oxidation occur at A and reduction occur at B. Okay, the standard reduction potential. Look, the reduction potentials are given. So we have to find the voltage of this cell. Now keep this thing in your mind that when oxidation occur on electrode, then the oxidation potential will be positive in this case, and reduction potential value will be negative. Okay, when the oxidation occur on electrode, its oxidation potential value will be positive and reduction potential value will be negative. Now if the reduction occur on electrode, its oxidation potential value will be negative and reduction potential value will be positive. Okay, now look at here. In case of A, the oxidation has occurred, but look, the value is given the reduction. Okay, the reduction potential value is given, that's why it is negative. Okay, in case of oxidation has occurred, but the value is given of reduction potential, that's why it is negative value. Look on B, the reduction has occurred and the value is also given of reduction, so that's why it is positive. Now we have to calculate the voltage. Now the formula for voltage is reduction potential of the substance which is reduced. Now look at here, B is reduced, so we have to put the value of B here. Reduction potential minus reduction potential of the substance which is oxidized. Look, A is oxidized, so we have to put the value of this one, minus 13.13. Okay, minus 0.13. Now 0.080 minus 0.13. Now when we calculate this one, so we will get D. Okay, minus 0.93 voltage. The answer will be 0.93 voltage. A spontaneous reaction is for galvanic cell, as non-spontaneous reaction is for. So we know that non-spontaneous reaction occur in Nelson in ground cell. Okay, so here option C is correct because these two are the types of electrolytic cell. We know that in electrolytic cell the non-spontaneous reaction occur, so here option C is correct, and these two are the types of electrolytic cells. In Daniell cell a spontaneous reaction occur, so the required is non-spontaneous, so C is the correct option. The branch of chemistry which deals with the interconversion of electrical energy and chemical energy is electrochemistry. This branch is called electrochemistry. So this one was the last MCQ of electrochemistry. If you have any problem in any MCQ, then write in the comment section. Allah Hafiz.